Hey, welcome. All right, so we're going to do a little bit more with our rocket engine that we just did. So Matthew, walk us through this data here. So when we looked at our graph, Matthew, we found that the starting time was at 15 seconds and then finished at about 17 seconds. And so then what do we get out of there?
Get change the time to 2.02 seconds, but we rounded down in this case just so we can get an easier number to work with.
Okay. And then where are we getting our 19 Newton seconds from for the possible impulse this rocket could produce?
The 19 Newton seconds is coming from the 2 seconds we have from change in time, and we're doing that with our standard 9.5 newtons.
Okay. And so then we multiply those and we get 19 Newton seconds. Now that represents the change in momentum that we could get, which is read by delta lowercase p here. And momentum is equal to mass times velocity. So if we change our momentum, we could change our velocity. If we know the mass of the rocket that we're going to launch with this rocket engine, then we could actually figure out the final velocity that the rocket will have if we disregard any effects of gravity on it. And so let's take a look at how we got the mass of the rocket over here. So here is the rocket that we're hoping to launch with this bad boy, and we're putting in another rocket engine here that we used. So we're getting the mass of both those together, and it comes out to about 180 grams. Now that we have to convert into kilograms to get them in SI units, which is going to be 0.18 kilograms. So if we bring that back over here to our math, that's where we put in for M the 0.18 kilograms. And then that's going to give us our change of velocity, final velocity minus initial. Initial velocity is going to be 0 meters per second because we're going to launch from rest. And so then doing the math, we're going to get 105.6 meters per second is the possible final velocity. All right, thanks for mathing with us, and you have an awesome day.